Hey guys, hope you try this practice problem. So here we have a large warehouse and these are the dimensions. Let's draw that real quick. It's 100 by 100 with a height of 10. So it's a square base, 100 by 100 with a height of 10. So something like this, and maybe your 3D box looks better, but it's essentially a box. You don't have to draw it, but I find that it helps. We want to know what is the total weight of air inside of it. So what is the weight of air? And weight, every time you see weight, you're always just going to write mass times gravity. I know gravity, we're going to use it as an approximation that gravity is 10 instead of 9.8, just to make life easier. So really, to find the weight, I have to find the mass, and then I just plug it in here. But how do we find the mass of air inside of this thing? Well, recently, we talked about two things. We talked about density and pressure. And I want to write those two equations real quick. So density is mass over volume, and pressure is force over area. Okay? Now we're talking about air, and I know the density of air, and I know the pressure of air. If I'm looking for mass, I'm going to use this equation here. Very straightforward. So if you ever forget, just write the two of them, and then that might help. So mass equals density, rho, times volume. And the density of air, you have to remember, is 1.2 kilograms per cubic meter. Okay, and the volume is just a multiplication of all these things. So it's 100 times 100 times 10 cubic meter. Cubic meter cancels, and you're left with 1.2 times 10 to the, just got to count this, 1, 2, 3, 4, 5, to the fifth. And this is the amount of kilograms. Now we're not done because we want the weight, and so we have to multiply that by 9.8, or in this case we're doing 10. So it's going to be 1.2 times 10 to the fifth kilograms times gravity, which is 10. So this is going to be 1.2 times 10 to the 6 newtons, and I'm using the standard units for gravity, meters per second square, standard unit for mass, kilograms, so I get the standard unit for weight, which is newtons. Cool. Now for part B, let's make that blue. I want to know how much pressure does this weight of air, these 1.2 times 10 to the 6 newtons, how much pressure does that apply on the floor? Okay, so to find pressure, I just go to the pressure equation. So pressure is force over area. Force over area. Now what is the force? Well, it's the force of the weights. So I can rewrite this as mg. Okay, and I know mg because we just calculated right here. So this is going to be 1.2 times 10 to the 6 divided by the area. So the area is the area of the floor, and it's kind of hard to see that because now I'm just making lines everywhere. But I hope you see that this is 100 times 100. So this is square meters. This is newtons. Okay, and Newton per square meter is a Pascal. So the pressure here is going to be 120. Okay, and that's because you have, let me do this a little bit slower. That's because you have 1.2 times 10 to the 6 divided by 10 to the 4th, because there's 4 zeros. These cancel, you're left with a little 2 there. So I just have to add 2 zeros. So this moves over, and then I add another 1. So this is 120 Pascal is the pressure. Okay, it's not a lot of pressure because the column of air above the floor is only 10 meters. So there's not that much air that the floor is responsible for supporting. Okay, that's why the pressure is not very much. Now I could have done this a little bit differently, and I showed you this on a previous video, but you could have written, I'm going to do this really quickly because I'm essentially deriving it. So I'm going to say that P is mg over A. Remember that mass is rho times volume right here, and that volume is the 3 dimensions, right? It is the width times height times depth, doesn't matter the order. So if I put this here, rho times width times height times depth times gravity, and I divide by the base, by the area of the base, which is width times depth, these guys cancel. The one last time I'm showing you this, and the pressure turns out to be rho g H. So you could have done it this way. You could have said the density of air is 1.2, gravity is 10, the height is 10, therefore this is 120 Pascal. Okay, so this is sort of an alternative way you could have done this, and I'm showing you just to sort of solidify that you can also use this equation whenever you have a column of air above you and you know the height of that column of air. Cool, let me get out of the way so you can get that, and that's it for this one. Let's keep going.